Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at arithmetic series. So by the end of this, I want you to be able to use this formula here to calculate the partial sum of an arithmetic series. So what is an arithmetic series and how does it differ from an arithmetic sequence? Well, this, for example, is an arithmetic sequence. So it's an arithmetic sequence because each term is 5 more than the last. It's going up by the same amount each time. It's going up by 5. 5 is the common difference. So that's an arithmetic sequence. An arithmetic series, on the other hand, is actually just the sum of an arithmetic sequence. If I were to add up all these terms, this is what we call an arithmetic series. So arithmetic sequences, they usually go on forever, and that's why they have these dots at the end. But when we're talking about an arithmetic series, we don't want to add up all the terms, we only want to add up some of the terms. That's why we call it a partial sum. So here we have 11 terms of the sequence. So in this series, we're adding up 11 numbers. So we refer to this as S11. That's the partial sum. It is the sum of the first 11 terms of this sequence. So what's a quick way that we could add up all of these numbers? Well, it would take a while. I'm too lazy to put all of these on my calculator. See, what I can do is this. I can just find, because it's an arithmetic series, I can just find the average value of these terms and then multiply it by how many there are. So what is the average of all of these numbers here? Well, the average of all of these numbers, all I need to do is add the first and the last and divide by 2. So the average of all of these numbers in the sequence is 17. 17's here. The average of 12 and 22 is 17. 7 and 27 is 17. 2 and 32 minus 3 and 37 minus 8 and 42. The average of each of these terms is 17. So I can just take this average 17 and multiply it by 11 because there are 11 terms. So I want to times 11 by the whole thing, and I get 187. See, what I'm doing with an arithmetic sequence, it works that you can average the terms like that, only if it's arithmetic. What I'm doing is I'm taking the first term and the last term, which I'll call L, dividing by 2, that's the average term, and I'm timesing this by N, the number of terms. So this is the formula for the partial sum, the sum of the first n terms of an arithmetic sequence, which is the first n terms of an arithmetic series. The problem is, however, I don't always know this term. I don't know what the last term will be. I do know, however, that if there are n terms, and a is the first term, this will be the nth term. So what I can do is I can write this as a plus, now the nth term, the formula for the nth term of an arithmetic sequence is what we learned in a previous video. It's a plus n minus 1d. So all I've done to get from here to here is replace L with the formula for the nth term. So it doesn't matter if I move the 2 over here, I can just rewrite this as n over 2 times, of course, a plus a is 2a plus n minus 1d. That is how I get the formula for the sum, the partial sum of an arithmetic series. So let's now look at a couple of examples where I use this. So this is the kind of question that you might be asked. You might be given a series here and asked to calculate something like S20. This is saying calculate the sum of the first 20 terms of this series, minus 7, minus 4, minus 1, and so on. So we're just going to use the formula on the previous slide. So Sn equals n over 2, 2a plus n minus 1d. So if I'm calculating S20, I have that n equals 20. I know that a is the first term, so 2a is 2 times minus 7, plus n minus 1 in this case would be 19. And then the common difference you can see is 3. Each term's going up by 3. So this will be the sum of all of those 20 numbers. So putting that on your calculator, you get 430, which is much quicker than going to your calculator and doing -7 plus -4 plus -1 and so on. So let's try this question here, which is a little bit harder. The reason this is a little bit harder, I have all the numbers here, but I don't know which term this is. Is this the 30th term? Is it the 40th term? I don't know. So I'm going to need to figure that out, which term this is, in order to be able to calculate the sum. So I know that Tn equals a plus n minus 1d. That works for any arithmetic sequence. This is an arithmetic series because we're going down by 7 each time. So I can just substitute a for 78, and I can substitute d for -7, and I'll substitute Tn for -48. And then I'll solve for n. I want to find the value of n that makes Tn equal -48. That's the same as finding which number term is equal to -48. So I'll start by subtracting 78 from both sides. And then I'm going to divide each side by -7 and add 1 to both sides. This means that -48 is the 20th term of this series. So to find the sum of all this, I'm again finding S20. So because I know the last term, I can use a plus L over 2 if I like. So I go a plus L, first term plus last term divided by 2, and then I times that by 20 because there are 20 terms. And that gives me 300. But I can use the other formula if I prefer. So getting rid of this, I'm going to use the formula that I used up here. So I would get S20 equals n over 2, 2 times a plus n minus 1, which is 19, times d, which I figured out was -7. And putting that on my calculator, I get 300, the exact same number. All right, let's now look at one more question that's a little harder. So we're now going to find the sum of all integers between and including 1 and 200 that are not multiples of 7. So what I really want to do is find 1 plus 2 plus 3 all the way up to 200, but I don't want to include numbers like 7, so I skip 7, and of course I don't want to include numbers like 14 either. If I write it out like this is just going to take way too long. I need another way to do it. Problem with this isn't actually an arithmetic series, so I don't have a formula to find all of these numbers because I'm skipping each 7. I do know, however, I can use a formula to find the sum of all numbers, all integers, between and including 1 and 200. This is an arithmetic series, so I can use the formula. The problem is this will include all the multiples of 7. It will include 7, 14, 21, and so on, all the way up to, so the highest multiple of 7 less than 200 is 196. I don't want to include these, so what I can do is I can find this sum and simply take away this sum. That won't be too hard because both of these are arithmetic series. So let's start with the sum of the first 200 numbers. That's actually really easy. So I'll just call that S200. So in this arithmetic series, the first term is A1. There are 200 terms, so n is 200, and d is also 1 because we're going up by 1. So it will be n over 2, 2 times a plus n minus 1 is 199 times d. So the answer I get is actually 20,100. That is the sum of the first 200 integers. So I'll call this one here, I'll just call it S star, the sum of this arithmetic series. Well, we know A is 7 and D is 7. How many terms would there be? Well, if you go 196 divided by 7, you get 28. There are 28 multiples of 7 less than 200. So the sum of this will be n over 2 times A plus n minus 1 times D. And the answer I get there is 2,842. So the sum of all integers between and including 1 and 200 that are not multiples of 7, it will simply be 20,100 minus 2,842. And that gives us the number 17,258, and we're done. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.